Our essential question is, what is a dilation and how do I dilate a shape? Now, it's entirely possible that we've already talked about dilation before this video. We're going to do a little more formal definition of a dilation. In fact, you've probably already gone through the properties of a dilation, but now we're going to actually take the definition of dilation and dilate something in a coordinate grid. So, first of all, let's clarify these definitions. The pre-image is the original or starting figure in a transformation. The image is the new or ending figure in a transformation. A dilation, specifically defined, it's a transformation which uses a center of dilation, we can abbreviate that as COD, and a scale factor to produce a similar image. So a transformation using a COD and a scale factor to produce a similar image. Remember, similar means it's going to be the same shape but just a different size. And then one thing you want to know about dilation, we can both reduce the original and make it smaller with a dilation, or we can enlarge an original and make it bigger. We can reduce the pre-image to create a smaller image. We can enlarge the pre-image to create a bigger image. And then last definition here, if we know what a center of dilation is, we better define what a scale factor is. If a dilation has a scale factor, what is that? A scale factor is a ratio which describes a dilation. And here's your values. If the scale factor is between 0 and 1, then we're reducing the pre-image. If it's greater than 1, we are enlarging the pre-image. And if a scale factor is exactly 1 or 1 to 1, you're not reducing or enlarging, you're just creating a congruent image. Same image, same size, same shape. And then last thing on here, in big words, note, scale factor is always the measurement from a image divided by the corresponding measurement on the pre-image. It's never the reverse of that. It's always image over pre-image. Last thing on here before we get started with our work is, if you would, class, under pre-image, after the definition, put capital letter PI here to represent pre-image, and put capital letter I right here to represent image. All right, let's go ahead and do some dilations in a coordinate grid now. So for our example, let's do an enlargement. Oops, let's write the word enlarge. We're going to do an enlargement. So we're going to enlarge our pre-image, and let's use a scale factor of 2 to 1. And you know that a scale factor of 2 to 1, let's put this in parentheses, that means our scale factor is 2 over 1. 2 to 1 means 2 over 1. Now notice, class, since our scale factor is 2 over 1, that's greater than 1, that means we're enlarging. So a scale factor greater than 1 means we're going to enlarge. All right, here is our transformation notation for a scale factor of 2 to 1, or 2. We're going to take each coordinate and multiply it times 2. Remember, when we are dilating on a coordinate grid, we are using the origin as the COD. So let's put a little note here. This is our center of dilation. Okay, let's find our A, B, and C values. I'm going to say, let's call this vertex A, and that's at 3, 1, and vertex B is at 3, 3. And I'll put it down here so it's not in the way. Vertex C is at 6, 3. So now we're going to go ahead and use our transformation notation. First, A started off as 3, 1. That's going to become A prime, and we're going to multiply x times 2, so 3 times 2 is 6. Y times 2, so 1 times 2 is 2. There's our A prime. B started off as 3, 3. That's going to become B prime. Let's look at our transformation notation. Multiply 3 times 2 is 6. Multiply our Y value. 3 times 2 is also 6. And then our C value started off as 6, 3. That means C prime is going to be 6 times 2, which is 12, and 3 times 2, which is 6. So running our original 3 points through our transformation notation with a scale factor of 2 gave us these 3 new coordinates. Let's go ahead and plot those. Our new A value, A prime, is 6, 2. So it's 6 comma, is it 6 comma 2? Let's take a look at that. Yes, so this is 3, 1. Yeah, 6 comma 2. So it's actually going to be right here. 1, 2, 3, 4, 5, 6, 1, 2. You know, I kind of wish I had drawn this C value somewhere else. I'm going to just move it slightly down. It's going to look kind of ugly, but let's just slide it down a little bit, just so it's not going to get in the way of our new coordinate. So here is our new value for A prime. And that's going to be, and again, how am I going to write that in here? All right, let's put a little arrow here. That's kind of messy. That's A prime. Then our B prime is going to be 6, 6, 6, and then 1, 2, 3, 4, 5, 6. There is our B prime. Something is not right here. Oh, I see what I did wrong. I counted from the wrong place. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. There's B prime. Then our C prime is 12, 6. That's going to be 12 is here. 1, 2, 3, 4, 5, 6. And there is our C prime. Let's go ahead and connect these together now. We've got B to C, B to A, and C to A. And there is our enlarged or dilated image. And if you want to write in here the actual notation of pre-image and image, this was our starting. Let's call that pre-image. This was our ending. That was our image. There is a dilation by a scale factor of 2, which means our image or our copy is twice as big as our original. I can actually check that. This side right here, AB, was 2 units before. Now it's 1, 2, 3, 4. That's twice as big. And from B to C was 1, 2, 3. Now it's 1, 2, 3, 4, 5, 6. So it definitely appears to have doubled in size. All right, let's do one more. Let's do a reduction. So we're going to reduce this pre-image. In fact, let's go ahead and label this as PI for pre-image. We're going to reduce. Let's use a scale factor of, instead of 2 to 1, let's do 1 to 2. And again, remember, since the first number is the top of our fraction, that's actually a scale factor of 1/2. Remember, if our scale factor is less than 1, we are reducing our pre-image and making a smaller image. All right, let's label our points. So let's call this point A, and I'm going to count those units. That appears to be -10, 8. Let's call this B. That looks like it's -8, 8. And here is our C value. That looks like it is -8, 4. So there's our 3 original points. Let's transform them with this transformation notation. So A started off as -10, 8. And now what we're doing is for A prime, we're taking half of these numbers. 1/2 times that number. 1/2 of -10 is -5. 1/2 of 8 is 4. Let's take B. B used to be at -8, 8. That means our B prime, half of -8 is -4. Half of 8 is 4. There's our transformed coordinate. And then C. C was -8, 4. C prime is going to become half of -8, which is -4, and half of 4, which is 2. Now, I gave you guys an example where all these numbers were even numbers, so they came out nice. Sometimes you'll end up with decimals, or like it could be -4.5 or 2.5. Don't worry about that. You can graph 0.5. I don't think I'll get any more crazy than that. So if it's not whole numbers, it'll at least, dividing by 2, you'll still get something with 0.5, and that is graphable. All right, let's plot these points. So A prime is at negative 1, 2, 3, 4, 5, 1, 2, 3, 4. Here is A prime. B prime is negative 1, 2, 3, 4. 1, 2, 3, 4. There is B prime. And C prime is negative 1, 2, 3, 4. 1, 2. And there is C prime. Let's go ahead and create a triangle with that. I'm going to connect these two together. You can see that got pretty small. And the question is, does it look like it's a reduction? Absolutely, it's a reduction. And if we want to just visibly check, does it look like we're reducing by a scale factor of 1/2? Let's check one of our legs. AB was 2 units, now AB is 1 unit. BC was 4 units long, now BC is 2 units. Looks like we did reduce that triangle by a scale factor of 1 to 2. One more thing on there, remember that we are using, in this case, the origin is our COD. So make a little note of that so we know we're using the origin as the center of dilation. All right, there's some good examples on how to enlarge or reduce a shape in a coordinate grid using scale factor.